Hey there, let's go ahead and look at the third chapter of the 7th grade textbook, 3.3 specifically, and we are going to be taking words and translating them into expressions or equations, and then sometimes you're going to be asked to solve them. So let's go ahead and take a look at this. Just a quick review that when we are looking at specific words like product of and quotient of, the sum of, the power of, various words like that, they mean certain things. So for instance, more than means to add. It translates specifically into add. Difference or less than translates into subtraction. Product of translates into multiplication. Quotient translates into division. And then sometimes we are given directions to do something to a specific power, and that is an exponent. Sum is also a word that you'll see for addition. And we just need to know that some of these end up inside of our expressional phrases. Let's get started. The problem I want to look at with you is from the textbook. It is number 1 in 3.3. It says the length of a rectangular room is 10 feet more than its width. So I'm going to write down the important pieces here. With length is 10 feet more than its width. And let's go ahead and translate that. If we were looking for the width, and let's go ahead and say that, we're looking for the length. Let's go ahead and say that width here is going to be represented by W and length is going to be represented by L. We're looking for the length, and we look back at our problem. Length has already been written for us because we've decided that L represents length. Length is often translated into an equal sign because that's exactly what we are trying to solve, or we are looking for. Is an arrow that points directly to what we're trying to solve. In this instance, it's length. It's pointing towards length. Length is 10 feet more than its width. So width is going to be on there. And what else is important here is that this length is 10 feet more than the width. If something is more than something else, remember we said that we were adding to it. And in this case, that's exactly what we're doing. We can put this in parentheses to show that we have to solve this first in order to find the length. It's not a matter of doing algebraic manipulation. And we do know that it is feet here. So let's take a peek at another one. Say, for instance, we were looking at the next problem. We're looking at number 2. And it says that the price of a burger is $6 less than that of a pizza. Now we need to figure out the price of the burger in terms of P. So in terms of P means that we are going to use the variable P, which in this instance is going to represent the price of the pizza. We don't know what it is, so we have to represent that price with a variable, in this case, P. So the price of a burger is, what are we looking for here is the first question we would ask, and we're looking for the price of a burger. So we could say, literally, price of burger. We could have chosen the variable B to represent burger. It doesn't really matter as long as we know whatever variable, whatever wordage we use, it is representing that burger. So the price of the burger is what we're looking for, and has made an appearance again. Equals. Is equals. So now let's look at the next part. We are looking, mind you, for the price of the burger. So we have in our phrase, the price of the burger is $6 less than a pizza. What that means is we are subtracting 6. 6 less than. 3 less than. 1 less than means that we are subtracting whatever that preceding number is. So we're subtracting 6. Well, what are we subtracting 6 from? We're subtracting 6 from pizza, or P in this instance. $6 less than a pizza, or the price of a pizza. And there we go.